Breakout 12, what is up? This is review 5.1 to 5.2. Hope you're having a good night, and we're going to get through some questions here. I anticipate about a 30-minute study session, so not too long. So you could log in, get those questions out there, throw them on the right side of the YouTube link there, and put those questions out there. I'm going to get started just as an overall review real quick, and more or less just to kind of go over some concept strategies and then go into specific problems as well if you have them. Feel free to pull them from the homework. Also feel free to pull them from the review, and we'll go through some together. Sound good? Let's do it. Let's do this thing. Again, this is review 5.1, 5.2. I've got 5 viewers already. Holla. That's what I'm talking about. Those that are from my Sweden followers, welcome. Welcome one and all. And let's get started. Let's do this thing. I'm going to share my screen here. And as I share my screen, I'm going to pop on over. Let's do this. Boom, boom. Hope you had a great Monday today, by the way. Just going to throw that out there. If you had a great Monday, just give a little whoop, whoop. Yep, I heard you, although you out there. All 4 of you, I hear what you're saying. And even as I'm starting to talk over concepts here, feel free, throw a little question out there, and we'll begin this this process right now. Cool, cool, cool. And we are good to go. All right. So a couple of things that I wanted to hit on that a lot of people had some questions on regarding just overall concepts, like how do I don't want to give the person, but there was actually someone today that was like, Coach, I do not know the fundamentals of this, and I'm trying to do this when I don't know the fundamentals. Hold on just a sec. I'm going to move from my favorite chair over here so I can kind of sit down. But I thought it was really good because they said, I don't know the fundamentals. How am I supposed to do these identities where it's sine, cosine, and tangent, not even numbers? Well, what we're going to do is hopefully try to give you a baseline of strategies to be able to help you with this. This is not perfect. This is not all the time, but it definitely is helpful, I believe, in going and attacking a lot of these. So again, these are all verifying or simplifying identities. And so this is just maybe something good just to hold on to for tomorrow, okay? First thing I want to do is look for basic identities, okay? This could involve a lot of things. A lot of the times, like one like that it looks like this, cosine of pi over 2 minus x. Just knowing that that simplifies, again, you'll have your identity sheet, but knowing that this simplifies to sine x is important to proceed with the problem. Or like, what is sine of negative x? Again, a basic identity that comes straight from my formula sheet, and it literally says that it's equal to negative sine of x. That's there. So any basic identities that look kind of out of place, I always try to plug in those values specifically for ones like that may look like this. The second thing I like to do is I look for, is there anything that is being squared? And this kind of goes with number 1. So this could be like underneath it. But if there is anything squared, and especially if I have something like 1 minus cosine squared of x, knowing that that can, like literally I could plug sine squared in for this, that involves my Pythagorean identities. And if, again, I see something that's squared, it's not all the time, but definitely a strategy is plugging in and simplifying using Pythagorean identities. Step 3 involves maybe a couple things. So like if I multiply and maybe even divide, rather than maybe adding and subtracting. Now, this has been a huge, huge issue, I know, for some of us in terms of like, hey, what do I do when I multiply and divide, and what do I do when I add and subtract? Maybe a good example of this is if I had sine over 1 multiplied by cosine over sine. Well, when I multiply across on this, this would end up getting me sine cosine over sine, which allows me to actually cancel out the sine on top and bottom, giving me cosine. Now, if I were to divide this, let's say I had sine over sine over cosine, right? I would take the bottom, flip it to the top, and what would be happening is this sine, which would be over 1, is multiplied by the reciprocal, which would be cosine over sine, because again, if I divide, I flip the bottom to the top, and then I cancel. Little cancel party gets me to cosine. So that would be more multiplying and dividing. When I add and subtract, it's much different, and many of you have seen this here, where if I were to, let's say, have something that looked like this or even subtracted, does not matter. What I'm looking at doing here is getting a common denominator. This is huge. Understanding this concept is absolutely huge to your success tomorrow. So if I put cosine over cosine here, I'm then able to say, okay, this could then equal, now watch this, the common denominator is on the bottom of everything once I get that common denominator. And again, every fraction must have it when I'm adding. That's separated by the addition sign or subtraction sign. So this would be sine plus cosine squared, okay? So again, that's pretty important when proceeding forward. And step number 4 would be more or less, kind of go back here, kind of just do this, a window wash this. All right, let's go to this part. Now, the fourth one, I would say would be like factor. Factoring can come in different forms. You can have a GCF, which we saw today. If I had sine squared of x minus sine to the 4th x, which was our example from our review, we say, what is in common? Well, sine squared is in common. When I pull it out from this shared, the big thing is what is left over here and here. Well, this would not be 0 because sine squared over sine squared is simply 1. But when I look at sine to the 4th, if I look at sine squared, a sine squared is left over, and then I could kind of go forward off that. That's called GCF. The second thing we can do is if we have sine squared x minus tangent squared x, I could actually factor this. If I could take the square root of both with a minus in the middle, I can then factor, I go going whoop, whoop, like that, and square root of sine squared would be simply sine of x, and the square root of tangent squared is tangent of x, And so what you've got is sine of x plus tangent of x and sine of x minus tangent of x. And so again, that we call this difference of two squares. So this is DOTS, GCF was at the top. Let's go to the third one. Third one's a little different again. Just kind of goes off that. If we had, let's say, sine squared x plus sine of x minus 6, this would be one where we'd plug x in for sine, and we would get x squared plus x minus 6. And we would say, okay, what two numbers multiplied equal -6, but when added get me 1? And that'd be plus 3 and minus 2. And then we'd put x in for each. We'd plug back in that sine of x, so we get sine of x plus 3 and sine of x minus 2. And that's how I would factor at this point. This would just be, this is like a trinomial, but it's just kind of our basic version. I always call it basic because that's usually what you think of when you think of factoring. The last one is where a is not equal to 1. It's the same idea, except let's say we had 2 sine squared x plus 3 sine of x minus, trying to think of one that might be easy. Minus 2, would that work? Yeah, I think that would work there. So in this example, again, we plug x in for sine, and we go after it as if we're doing the a times c method. So we come down yonder or down here. We get 2x we put in for both within the method that I use. I use a times c, which would be 2 times -2, which is -4. I then say, after I do my a times c, what two numbers multiply that equal -4, but when added equal 3? And that would be +4 and -1. I take out what's in common, so there's a 2 out in common here. So if I were to simplify, I'd get x plus 2 multiplied by 2x minus 1. And that would be the greater than 1 part, okay? Cool. So that's going through steps 1 through 4. Trying to think of any other ones that were there. I think the fifth one I'll put over here is conjugate. The conjugate can be used anytime I have like 1 over 1 minus sign. If this isn't squared, we can't use the Pythagorean identity as in step 2. So one way we can do this is just simply multiply by 1 over or 1 plus sine of x, both top and bottom. So these are some strategies to be able to help us. And then when in doubt, change it to sine and cosine and see what happens. Okay, change the sine and cosine and then repeat with numbers 1 through 6 there. Cool. All right, that was a lot of information. I think I took the first 10 minutes to really walk through that. I hope that was helpful for you. I'm not seeing a whole lot of questions on this side, so feel free to throw some questions out there. If I don't see very many questions, I know there are a couple viewers out there. If I don't see very many questions, I'm just going to go straight into some other problems that may or may not be helpful. So, hey, I want to be of help to you, so just make sure you touch base with me, and we'll go from there. The one that I did want to look at is this one on E, the simplifying of sine squared y over 1 minus cosine. There's a couple ways that we could go here. Some people actually change the sine squared to 1 minus cosine squared. That one's maybe less obvious. This comes from our steps. So let's go straight to our steps that we were looking at. Let me go to this other one. I'm sorry. Here we go. So I start with the top. Is there an identity? No. Is there a squared? Well, there is a squared. Some of you could change this to 1 minus cosine squared, which would be okay, but maybe that's less obvious. So let's go to the next one. Are we multiplying and dividing? Well, not necessarily, because the 1 minus cosine is all underneath sine squared, so that doesn't really help me. Adding and subtracting? No, not really. Factoring? No, there's not really good factoring at all. And kind of go down. Okay, conjugate. Look down here. The 1 minus sine, just like in this problem over here, is 1 minus cosine. We could multiply this both top and bottom by its conjugate, and let's see what happens. So if we did 1 plus cosine, top and bottom, we would be left. And again, we want to show this works. So that's a big deal too. We're going to leave the top here by just saying, okay, that's sine squared y over 1 plus cosine y. And on the bottom, we notice that we could distribute this. So 1 times 1 is 1. 1 times cosine y is cosine y. Then I go to the negative cosine y times 1 is negative cosine y. And negative cosine times cosine is negative cosine squared y. So we cancel here and here. We're left with 1 minus cosine squared, which is sine squared y on the bottom. And we have on the top sine squared y times 1 plus cosine y. And the question is what we could cancel here, boom and boom, leaving us just with 1 plus cosine of y. And I think that one was probably the tougher of the problems in the simplifying on part 2. I thought they were the tougher ones. Over here, this comes back to identities where the cotangent can change the tangent of x, and we have cosine x. Once I get to kind of these back-to-back being multiplied, I could change tangent to sine over cosine. A lot of times you'll see me kind of do equal signs to let me know where I'm at. And then I'll put cosine of x over 1. Whoop, whoop. There you are. Little sine x action is how we would do part D. Okay? All right. Oh, yes. Red, that's a good one. Let's go to that one. Let's go to secant. Where are you? Secant minus cosine equals sine times tangent. Okay. So the first thing I would do on D, I would freeze this right side, okay? We're going to freeze it. I can't do anything to that side other than just look and try to match up that left side to the right side. The next question I have is, okay, what is occurring? So if I come to my stuff here, basic identities, there's not really any that are crazy out there. There's nothing squared. We are adding and subtracting, but they're not fractions, so we can't do much yet with that. We can't really factor a GCF, and there's no square root. There's a minus in the middle, but I can't take the square root of both. There's not a trinomial here, so we can't do that. So when in doubt, we're going to change the sine and cosine. So cosine will turn into 1 over cosine of x. And then we'll do minus cosine of x over 1. Okay, so we've got a good start here. The next question is what's our next step? Well, we have two fractions with a minus in the middle that we're subtracting. We cannot cancel here and here because we're not multiplying. But what we can do is get that common denominator of cosine of x, both top and bottom. So what we've got is 1 over cosine of x minus cosine times cosine is cosine squared of x. And then this is all over cosine of x. So this would be step 1. Step 2, once I get that common denominator, I can simply put 1 minus cosine squared of x over cosine of x there. And before I kind of see anything, I notice that 1 minus cosine, I'll kind of put it over here. 1 minus cosine squared is an identity which transforms to sine squared over cosine. Now, probably the toughest part is to then say, what do I do next? Well, if you got to this point, you're going to get a lot of credit. How much? It's going to be probably 75% of this problem. This is pretty far. You did a pretty good job here. But we're not there yet. We're still not there. What can I do to get from here to here? Well, notice that I've already got one sign at the top, right? I've already got one sign at the top. So I'm going to actually pull that out because it already matches to the right side. So I'd have sine of x, it's pulled out, right? The question is what's left over? Well, there was 2 on the top. So we're left with 1 on the top left over that 1 cosine. Well, that sine represents the sine of x. And this sine over cosine represents tangent of x, and that's how we get from here down to sine x, tangent of x within the given problem. Okay? Cool. Yeah, that's a good one. That's a really good one. Yeah, let's go to the next one. Letter E is probably the toughest problem that's on here. I like it because it really challenged me, or just challenged maybe a lot of us in terms of, hey, what one do I use? And I love the fact that this one you could use a lot of different strategies. So I'm going to do it this way, though. I'm going to approach this one as if I was going straight from my stuff here. Okay, so verifying identity. So number 1, we look for basic identities. I don't see any that are crazy out there. 2, is there anything squared? Nope, nothing squared. Can we multiply and divide? I don't see any multiplying and dividing here. Maybe these, but these aren't really fractions. Are we adding and subtracting? Well, this is where we could kind of step back here and understand that this -1 is kind of all by itself. And what we can do is to get this to where we could combine it with this other side, this fraction on the left, we could get common denominators. So we're going to do cosine theta, cotangent theta, all over 1 minus sine theta. And with this -1, I'm going to multiply by 1 minus sine on both top and bottom. Okay, so here we are. Okay, as I do this, I notice that because I have a common denominator, which was 1 minus sine, again, I included to this equals 1. Again, we're freezing that cosecant. We're going to put 1 minus sine at the top. And what we're going to do now is on this top side, we're just going to leave this as cosine of theta, cotangent of theta. And this -1, and yes, this minus goes to that negative, is going to distribute to both the 1 and the minus sign to make -1. And then -1 times negative sine is positive sine of theta. Okay? Now, be careful. A lot of times people want to cancel these out, but we actually can't because they're not being multiplied. They're just being added and subtracted. Now, if I had a parenthesis and they would be multiplied here, we absolutely could, but we can't just take it out of thin air to get us to that other side. So now on the top, we're going to look to see, can we simplify it all on this top side? And because the bottom's pretty much frozen. It's our common denominator, and it's pretty much frozen. And if I went over here, I noticed that I went all the way through 3, 4. I can't really factor. There's nothing I can take out. And so when in doubt, here's the deal. We got to go straight to sine and cosine. So this would be cosine. I'm just doing, this is going to be in white, just the top part. Cosine of theta, and cotangent would be cosine of theta over sine theta. Just so you could see this, I'm putting this over 1, okay? And then I'm going to put -1 and plus sine. Now, once I simplify this, going into step 4, we're multiplying across to get cosine squared of theta over sine of theta. Now, this, again, does seem a little bit tough, and it's tricky, okay? Again, because this is just the top side. But keep going with the process. Now we've got a fraction, a whole number, and a whole number just on the top side. But we could actually combine this if we simply put a sign in for both, right? Put a sign in on the bottom. So what we could have happen is, and I'll do this in green, is I could multiply top and bottom by sine of theta to get that common denominator again. So we do it top, we do it on bottom. Once I do that, my common denominator is all over sine of theta. And on the top, I get cosine squared theta minus sine of theta plus sine squared of theta. Now, the sine squared plus cosine squared, you'll notice right up here, is equal to 1, right? So really what we have here, and I'll kind of put it right on this side, is 1 minus sine theta over sine. And now we can't forget what we had down at the bottom of the 1 minus sine up above. So this would be 1 minus sine theta over 1. Again, to simplify this, we flip it to the top, multiplying by 1 over 1 minus sine of theta. And I could cancel and cancel because it's by itself and it's exactly the same, leaving me with 1 over sine of theta, which would be equal to cosecant of theta. Okay. Again, I wanted to show this to you because this is definitely a way of doing it. Another way of doing this is come back up here. So this is actually cosine squared over sine. So I'm going to backtrack. You can rewind the video. So up here, this is cosine squared over sine. So this is just an easier way of doing this, all over 1 minus sine, and then minus 1. If I turn cosecant squared in terms of sine, that would be 1 minus sine squared of theta. And if I were to factor this up on top, and I'll put this in yellow down below, if I were to factor this here, I would get 1 plus sine times 1 minus sine. And then that's all over sine. And then this would be all over 1 minus sine of theta over 1. And then I could flip this to the top. Again, this is just another way of doing it. If you decided to do it this way, that's great. Since they're being multiplied, I can actually cancel out. And then that would leave me with 1 plus sine of theta over sine of theta, and then minus 1, I could get common denominators and go from there. So again, just kind of and then that would get me to my answer, because then I would have, I'll just show it to you, 1 plus sine theta over sine theta minus 1, multiply top and bottom by sine to get a common denominator, 1 plus sine minus sine right here. The signs would cancel, giving me 1 over sine, which is cosecant. So I just want you to kind of see that there are multiple ways of attacking this. And the big thing is just making sure you show your work and show me, prove to me that you know what you're doing on the given problem that's at hand. Here's another one with the basic identities where this one's not too bad, where the top part is actually sine of x and the bottom part is cosine of x, which equals tangent of x. Just a heads up on that. The important part of these is making sure that you don't just memorize the actual problem itself, because it can be easy to do that. The big thing is to understand the concept so that you could apply it in any given situation. And that's why these strategies here are good just to remember and be familiar with before you actually take the test tomorrow. Okay. I do want to do this one. I actually messed up on this on the answer sheet. I looked at my I looked at the problem thinking that it was x and x, but it was actually x and y. And so let's do it. One strategy I did want to kind of go over with you is this thought of if the bottom is 1, meaning there's no plus, it's just multiplied together. A good example of this might be, and I'm just throwing this down here, if I had sine squared plus 1 all over cosine, it is appropriate because there's only one value, or if it's multiplied, you could, whatever's next to it. As long as there's no addition, you could actually put it underneath both. So this could also be sine squared x over cosine x plus 1 over cosine x. And that would be sufficient for simplifying off of what you just saw on the left side. So in this one, we're going to do that. We're going to put tangent x, cotangent y underneath tangent of x and underneath cotangent of y because they're multiplied. So we would want to show this. We'd get tangent of x over tan x cotangent y plus cotangent y over tangent x cotangent y. These cancel right here. And also the cotangent y's cancel, leaving me with 1 over cotangent y plus 1 over tangent of x. And if I were to simplify, 1 over cotangent of y is tangent of y, and 1 over tangent of x is cotangent of x. And there you are. You matched it up to that right side. Some of you also came to me, I think, this morning, and you went and did the sine over cosine for tangent up here and cosine over sine. That's fine. Just make sure that the variable follows the sine and cosine as well. Okay. Cool. Do y'all have any other questions for me? I'll kind of hang loose here. Went through a lot of problems today. I think we went through close, if not all, of the ones on the review sheet. So turning that in, I don't see that being a huge issue. We already did that one. Yeah, this one here is also one that you kind of see how I looked at the right side. I actually went down, I followed this all the way through and then hit a brick wall to match the right to the left side. And so I went to the left side, and you'll see kind of my thought process there. Some of you went after it a little differently, which I love. But this is, again, just so you can kind of see that sometimes that happens. I'll hit a brick wall, and then I have to freeze and say, okay, let's go to the other side and attack it there. Cool. Awesome. I'm going to hang loose for just a second. I see 7 are watching right now. If you have any other questions at all, throw them out there to me, and we'll go through some of those together. If there are no other questions, that's absolutely fine. We can take a look at it. Do this for me for tomorrow. Yeah, don't forget the +3, the paragraph for the +3 points of where verifying identities can be used in the real world. So you can bring that in for tomorrow. I'm trying to think of anything else. The review sheet is not required, but definitely something that could be a benefit to you. And yeah, I think that's good. Let's go over. Oh, yes. This is a good one. Red, you just brought up a really good point, and I'm glad you hit this one. This is good. Okay, so the one that I just got here was off the homework. It was cosine to the third x, sine squared x. And while I'm doing this, if you have any other questions, throw them out there, and you can always rewind the video from this point. So if you want to, you can feel free to do that. And then we have it's equal to sine squared x minus sine to the fourth x. I think it's times cosine of x. Okay, good. I would say the most complicated side is this right side. And I'm going to freeze my left, okay? Freeze the left. So the question is are there any identities that are like out there? I don't see any right now. Now, the second thing is Pythagorean identities. Well, I see a squared, but there's nothing like 1 minus sine squared, and it doesn't seem like it's going to get me closer to the answer. So I would say let's hold off on that for just a second. The third one was factoring. Well, I could look and see, is there a GCF within the inside? Well, because the cosine is pulled to the outside, we're looking at the GCF on the inside of the parentheses. And in fact, there is one I think we did in class today. and the shared value would be sine squared. So we pull out a sine squared x. We'll leave that cosine x, by the way. This drops down. So we'll leave this here. So if I bring out a sine squared x, I'm left with 1 minus, and if I pull out a sine squared here, I'm left with sine squared. Be careful, don't put 0 for this. A lot of times when you take out what's already there, a lot of times people put that 0. Just make sure you fill that in with 1, because if you divide the same thing by each other, you produce 1. We then say, is there anything like an identity or anything that we could do? And we remember that 1 minus sine squared is a simplified Pythagorean identity of cosine squared that we could plug in for 1 minus sine squared. And there we are. Plug this in. Because we multiply, we got to be careful here. Normally we distribute, right? So if I had sine times 1 plus cosine of x, this would distribute to both. But because these are all being multiplied, we just multiply 1 to the next to the next. So cosine squared times sine squared times cosine, we could combine these two, and cosine squared times cosine is cosine to the third of x, and then we have our sine squared of x on that right side to match it up to my left. Cool? Cool, cool. If you have any other questions, come on by tomorrow morning. I'm going to be hanging out there going over problems with people that need some extra help. So if you need to, we could kind of walk through some of these things that you may have issues on, and we'll rock and roll. Appreciate y'all so much for showing up, showing out, and y'all have a phenomenal day. Love y'all. See you later. Bye.